Upper limb paralysis is a leading cause of disability in India. Over 1.8 million Indians suffer from stroke every year, and at least 10% of all patients injured in road accidents suffer brachial plexus injury and spinal cord injuries. The physiotherapy needs of the patients are unmet due to lack of required number of qualified physiotherapists. The project started as a mini project by Arshad A. Samad and Menino Fruto of MTech Robotics and Automation 2016-18 batch. CET Center for Interdisciplinary Research later collaborated with ICFOS to realize a final prototype.
This exoskeleton can work as a wearable physiotherapeutic assistance for those who are suffering from upper limb partial paralysis disorder. It is having 5 degrees of freedom and it is controlled to sync with the natural movements of the user.
To make it wearable, 90% of all the parts were made using 3D printed lightweight materials. To start with, we tried to address the physiotherapy needs of one of the team members who was suffering from the brachial plexus injury, and we succeeded in that endeavor.
This multidisciplinary project requires in-depth understanding in electrical, electronics and mechanical engineering systems as well as the human body dynamics. Most importantly, this is an open hardware project so that anyone can learn it and modify it.
The prototype is currently in its final stage, receiving appreciation and support from many organizations to be a commercial product.
In this project, a petrol engine driven auto rickshaw was retrofitted with an electric motor at the front wheel, and it was converted to a hybrid electric auto rickshaw. The hybrid vehicle has 2 power sources, one the IC engine and second the BLDC motor. The IC engine drives the rear wheels of the vehicle through a transmission. The BLDC hub motor drives the front wheel of the vehicle. In a normal auto rickshaw, when the engine experiences a heavy load, such as when starting from an incline, fuel consumption goes high as well as the engine emissions. Using an engine RPM sensor, throttle position sensor and vehicle speed sensor, the main controller estimates the engine load and determines what percentage of assistance should be given to the IC engine using the BLDC hub motor. Hence, with the hybrid electric system on, the main controller prevents the IC engine from experiencing a heavy load and thereby improves the fuel efficiency as well as reduces the engine emissions.